f of x plus delta x minus f of x divided with delta x limit delta x tends to 0. It means changing the function value f of x. This first term is a change in f of x with the, from f of x. That is a net change in y. It is a ratio of change in y divided by change in x when delta x is very, very small. It is tending to 0. It is the limit. This is the meaning of derivative. Limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. This delta x should be very, very small. It should tend towards 0. That limit should exist also. And when I say limit, it means both left side as well as right side limit. That means both it includes 0 minus and 0 plus. That means the difference is positive as well as negative. Both sides will be approaching. So the limit exists means not one side limit. Both limits should exist. Otherwise, if both limit does not exist, both limits only one limit exists, then it is not differentiable. And again, that both limits should be same. The left side limit, I will give an example later. Left side limit equal to right side limit. I'll give an example later in this case. 0 minus equal to 0 plus. We will just give some formula for functions. These are all derivative functions. Derivative formula. Suppose f of x is a constant. F of x equal to c, a constant. A constant. d by dx of a constant is equal to 0. Derivative of a constant is 0. The next formula, d by dx of sum of two functions. Sum or difference of two functions. U and V are two functions of x. Either U plus V or U minus V. You can add two functions or subtract two functions. Derivative of such function is d by du by dx. I just say I'm revising the basic differentiation. That's all in this class. Du by dx plus or minus dv by dx. Where u and v are functions of x. Functions of x. So some are difference of two variables is some are difference of some are differences of derivative of the variables. This is derivative of u, derivative of v. You have to add after taking derivative. You can add and take it derivative or take derivative and add. As well as subtraction also the same rule applicable. Next one, some these basic things will be useful, so you can keep it in hand whenever you solve some problems. D by dx of d by dx of uv, product of two functions u and v, as I said, two functions of x. U and v are functions of x. D by dx of product of two functions is given by u into dv by dx plus v into du by dx. So this is a product of two functions. This is a product rule. Then d by dx of constant multiplied by function. D by dx of constant c. C is a constant multiplied by u. U is a function of x equal to, you take out c out, c multiplied by derivative of u, c into du by dx. I'll give some examples also for this formula. I'll show how to apply this formula. D by dx of u by v formula. Division of two functions. D by dx of u by v. U and v are functions of x. U by v given by v into v multiplied by du by dx. V multiplied by du by dx minus u multiplied by dv by dx divided by whole divided by v square, where u and v are functions of x. D by dx of x over m. X is independent variable raised to m. M can be anything, 2, 3, etc. Anything is given by m times x power m minus 1. I'll give some examples. D by dx of x power 4. Here m equal to 4. So m is 4. So 4 times x power m minus 1 is x cubed. We will also apply for this. I should get the same result. Product rule. We can use it as a product of two variables, right? D by dx of u and v. U multiplied by v. I will take u is, I'll give u equal to x cubed. V equal to x. So it is a product of two functions, u and v. X power 4 is x power 3 multiplied by x. X power 3 multiplied by x. It is a product of two functions. We will use the product rule. As per the product rule, u times dv by dx. So here I have written u times dv by dx. U is x power 3 multiplied by derivative of x. Derivative of x is x power 1. 1 into x power 1 minus 1 x power 0. That means 1. X power 1 derivative right here. 1 into x power 1 minus 1 equal to 1 into x power 0 equal to 1. So x power 3 multiplied by 1 plus x into du by dx. Right? That is derivative of x power 3 is m is equal to 3. So 3 x square. 3 will come in the beginning, like x power 4 is 4x cubed, 3x square. This is nothing but power 3 plus 3x cubed equal. There are 2 times of x cubed. If we add them, it is 4x cubed. So we got same formula. Derivative of x power 3, 4 is 4 times x cubed. Same thing we got. We just applied the product rule. Just I showed an example to apply the product rule. Now, for the same x power 4, suppose I will give an example for the division rule. d by dx of x cubed. We know that I will first write as per the formula m equal to 3 here. So 3 times x power 3 minus 1. That is x, 3 times, sorry, this is 3. 3 times x power 3 minus 1 equal to 3x square. Same thing we will apply u by v rule. D by dx of x power 4, x cubed is x power 4 divided by x. So u is x power 4, v equal to x. So v into du by dx, I have written here, v into du by dx. So x into derivative of x cubed, sorry, x power 4, right? V into derivative of u, that is x power 4. Derivative of x power 4 is 4x cubed. So x into 4x cubed minus u into du by dx. Let's see the formula here. Minus u into du by dx. This is u. Minus u into u instead of u, I substitute x power 4 into du by dx. Du by v equal to x means du by dx is 1. Because x power 1 means 1 into x power 1 minus 1. I have proved here. This x power 0 equal to 1. Derivative of x is 1. So x power 4 into 1. X power 4 into 1. Divided by v square. V is x. V square is x square. Let us verify this. This is x power 3 into x is x power 4. 4x power 4 minus x power 4 into 1 is x power 4 divided by x square. That is 3x power 4 3x power 4 by x square equal to 3x square. Same thing we got x cubed is 3x square. X power m formula. We got 3x square. Here also we got 3x square. Instead of direct formula, we used it u by v formula as a ratio of x power 4 divided by x. That we applied that formula and got the same result. This is the application of u by v formula. Whenever you have got two functions, you have to divide one function by other, you can apply u by v rule. Not rule. Division rule. This is division rule. Unit rule we saw earlier. U v equal to u into du by dx plus v into du by dx. And before going further, we will understand, try to understand geometrical meaning of derivative. Geometrically, what does derivative means? Suppose f of x is a curve like this. It is a curve, any curve. At a point x, this is a point x, that is a tangent. I draw a tangent at this point. The tangent. This is a point x cover y. Then there is a chord. It is a curve. It is generic curve. No specific. Let's call it as y equal to f of x. It is a curve. So on xy we draw a tangent and we draw a chord. It's the curve some point. The point is x plus delta x plus delta x, y plus delta y. That's the coordinate of the chord where it takes. Suppose this tangent at point is P. The chord is at Q. Q coordinate of Q is x plus delta x, comma y plus delta y. Let us fix P. Move Q. We slide Q towards P. It is coming down, down, down till it meets P. So, the difference in the x coordinate between P and Q, delta x. Right? This is delta x. The difference in y coordinate is delta y. So, what is derivative meaning? Dy by dx is delta x tends to 0. The limit delta x tends to 0. Power by delta x. So, when the delta x is tends to 0, that means when delta q has the x plus delta x. When the difference in the x coordinate tends to 0 means q is moving towards P. So delta x becoming smaller and smaller. So the derivative is given by that dy by dx is delta x limit delta x tends to 0, delta y by delta x. Delta y is y coordinate difference between P and Q. Delta x is x coordinate difference between P and Q. When Q is going towards P, when delta is becoming closer and closer to 0, Q touches P. Q becomes P. Then this chord becomes tangent. This chord. Draw this. The arrow is mentioned. This is a chord. This chord will become tangent when Q is going towards P. Then this chord will become a tangent. So slope of the tangent. What is the slope of the tangent? Is given by slope of the tangent. Is given by dy by dx. Because when delta x becomes smaller and smaller, Q will become closer and closer to P, and to one stage it will coincide with P, then it's called become tangent. So slope is given by, that slope of this line, the chord, is nothing but delta y by delta x. So when delta x tends to 0, then that becomes dy by dx. So geometrical meaning of derivative is slope of the tangent at xy. Slope of the tangent at xy. Slope of the tangent at xy. X comma y. That is the meaning of the derivative. I'll give an example. Let f of x at x comma y, f of x equal to x coin at 1 comma 1. X equal to 1, y equal to, or we can take different 1 comma 2. 1 comma sorry, 1, 2 comma 4. Yeah, y equal to x square means like a parabola. 2 comma 4. X equal to 2, y equal to 2 square 4. Now what is the meaning of the derivative? Slope at 2 comma 4. Yes. You will bring f of x, derivative of f of x du by dx is 2x, right? X power 4. X power 2 means take the 2 in the front. 2 into x power 2 minus 1. X power 2 minus 1 is 1. So x power is 2. So 2 into 2 is 4. So, so the derivative at 2 comma 4 is 4. So this is the meaning of derivative. Derivative is nothing but du by dx is nothing but slope of the tangent. At 2 comma 4, we saw that slope is 2 into 4, 2, 4. The slope of the line at 2 comma 4 is a parabola. At 2 comma 4, the slope is 4. Suppose like this. At 2 comma 4, draw a tangent. That's slope of the line. The angle theta. Tan theta is slope is 4. We input x square. That's a parabola. Then we come to inverse function. Suppose f of x equal to x plus 1. F of x is y. Y equal to f of x equal to x plus 1. What is x in terms of y? What is x in terms of y? We know that y equal to x plus 1 means x equal to y equal to x plus 1. What is x in terms of y? Okay. What is x in terms of y? X equal to what? That is inverse function. Y equal to x plus 1 is normal function. Inverse function is x you represent as a function of y. X equal to, we know that x equal to y minus 1. X equal to y minus 1. This is the inverse function. Condition, what is the condition for inverse? Yeah, all functions should have inverse? No, some functions will not have inverse. Condition for inverse. Why you put f of x? What is the condition for inverse of function to exist? Why you put f of x? X1 and x2 are 2 points. X1 and x2 are 2 points. X1 not equal to x2. F of x1 not equal to f of x2. This is a condition. This is an example where this condition is not obeyed. Y equal to x square. Suppose we take two values, x equal to plus 2 and x equal to minus 2. In one cases, y equal to 4. Right? Here this is x1, x1 equal to plus 2, x2 equal to minus 2. x1 is not equal to, obviously, x1 is not equal to x2. No, f of x1, f of x1 equal to f of x2. This is not obeyed. When they are not equal, f of x1 should not be equal to f of x2. But in this case, plus 2 square is 4, minus 2 whole square is 4. So f of x1 equal to f of x2. So this function doesn't have inverse. That means for 4, you cannot say which is x. It can be plus 2 or minus 2. It has two values. So this is not a function, right? This is not allowed. So this inverse does not exist. Because f of x1 is not equal to f of x1 equal to f of x2 when x1 is not equal to x2. Obviously, 2 and minus 2 are not equal, but the squares values plus 2 whole square is 4, minus 2 whole square is also 4. So they are equal. It is said to have inverse only if they are not equal. Here they are equal. So it doesn't have inverse. We cannot map 4 to inverse of 4 is what? We cannot tell whether it is plus 2, it could be minus 2 also. We cannot tell one particular value. So this is not allowed. So inverse does not exist. No inverse. The previous example, and go to the previous example, y equal to x plus 1. Does it have inverse? Yes. X equal to y minus 1. X equal to y minus 1. It is the unique inverse. It exists. If x1 is not equal to x2, x1 is equal to y1 minus 1, x2 equal to y2 minus 1. They are not equal. Right? So inverse exists. Whereas in the y equal to x square, inverse does not exist. I'll explain clearly difference. The function is y equal to x plus 1. I give x two values, x equal to 2, x equal to 2, and x equal to 2, y equal to 2 plus 1, 3. X equal to 4, y plus 1 is 5. So sorry, we will call it as x1 equal to 2 and x2 equal to 4. Obviously, these 2 and 4 are not equal. So as two y's we are getting. For x1 we get 3, for x2 we get 5. They are not equal. then the condition is obeyed. So this function has inverse. When I y equal to x square, both plus 2 gives 4, minus 2 also gives 4. Here they are not equal, but f of x is equal for both. So it does not have inverse. Then we come to chain rule. We call function of a function. Chain rule of a function. What is chain rule? Suppose y is a function of u. Y equal to f of u. A function of x. U equal to g of x. It is a function of x. Now, I want y is a function of u. U is a the u itself is another function of x. Y equal to f of u equal to g of x. I want derivative of y with respect to x. dy by dx equal to what? This is called chain rule. We can extend to mean u, v, w, etc. We can extend. But u and v, or u and x case I am writing. dy by dx equal to u1 by d1 by du multiplied by du by dx. Simple, just to way to remember is the du and du will cancel, du by dx we will get. Here example, y equal to u cubed. U equal to 4 square. And du by dx is we have to apply chain rule because y is a function of u is a function of x. What is du by dx? Du by du multiplied by du by dx. What is du by du? U cubed is 3 you have to bring in the front. Du by du equal to u cubed. 3 into u square. What is du by dx? X square is 2 you bring in the front. 2 into 4 8. 8x. So you have to multiply these two. 3 into u square multiplied by 8x. So u is 4x square, right? U equal to 4x square multiplied by 4x square, right? U square equal to 4x square multiplied by 4x square. It is 16x power 4. This chain rule is d over dx equal to 3u square multiplied by 8x. So 3 into u square is 6x power 4. Therefore, u square is 6 into x power 4. Multiplied by 8x. So this is 18 into 8. 18 into 8 multiplied by x power 4 into x is x power 5. Into x is 144 x power 5. So far, we talked about first derivative. You can have higher order derivative d over dx, d square divided by dx square, etc. D square minus divided by dx square equal to d by dx of d over by dx. This is higher order derivative. We can have any order of derivative. D by dx of d over by dx. Let's give an example for this. V equal to x cubed plus 2x square plus 5. D over dx is what? X cubed is 3x square, right? Mx power minus 1, m minus 1, you remember that. 3x square plus the addition to we are applying. Take the derivative and add it. Derivative of addition is integral derivative we have to add. So 3x, x cubed is 3x square, 2x square is 4x. This derivative of constant phi is 0. This is d over dx. What is d square y by dx square? Further you take a derivative. D over dx. You have to take the derivative. 3x square, if you take the derivative, 3 into 2, 6x. First term. Second term, 4x is 1 into x power 1 minus 1, 0. So 1 into x power 0 is 1. So 4 into 1, 4. This is the second derivative. Yes, sir, any derivatives. Some functions will be given as a relationship between x and y. They will not, y equal to f of x will be told as a relationship. We cannot explicitly write, but there will be a formula linking between x and y. How to get d over dx in those cases? Not explicitly given. There is called implicit differentiation. X and y are not given directly as a thing, but x and y are connected by a formula. Not explicitly the relationship is not given. Like y equal to x square, it's not given. But x and y are connected by a formula. Then how to get d over dx? For example, I'll give an example and explain this. X and y are connected as a formula. 2xy plus x square y square 3y equal to 0. So here the y is not given as a function of x directly. X and y are connected and they are given as a formula. 2xy plus x square y square plus 3y equal to 0. So we have to find that what is d over dx. That is what is d over dx or d square. In this case, they are interested in second derivative. D square y by dx square. That is the interest. D square y by dx square equal to 1. That is the question. So let us take that. We are not. So one thing is, it is not in a general anywhere. See a particular point and d square y by dx square and particular point. See, this particular point is more important, not general. If it is general, then we cannot use this. We want a particular point x comma y is minus 1 comma 1. We want at minus 1 comma 1. At this point only we want the second derivative. At this point only we want, not anywhere else. If you want general, you cannot use this. You have to express y explicitly in terms of x. That will be more complicated. But if you want d square by dx square, second derivative, at, at this particular point, minus 1 comma 1, we can use this differentiation. At this point only, only at, I write only. We don't want any other point. Only at this point we want. If you want general formula, we cannot use this. So we will take the derivative. What is the here afterwards? I will write y prime to represent. We can write like that. Dou by dx, we can write. It is a notation. Dou by dx, we can write as y prime. It is a notation. We can write like this. D square by dx square. D square y by dx square. We can write as y double prime. This is the notation. This is easy to write rather than d square by dx square. Y double prime. This means the same thing. So we will apply here. We will take the derivative. First derivative we will take. What is the first derivative? You apply u product formula. 2 into x into y. 2 is a constant. You can take it out. X and y they are multiplying. So what is that? You keep u second derivative 2 into x. Derivative of y is we write as y prime plus 2 into y derivative of x. Derivative of x power 1. 1 x power 1 minus 1 0. X power 0 is 1. So derivative of x is 1. 2 into y into 1. 2y. Right? I am skipping some steps. I didn't write explicitly. X square y square. X square into y square. Y square derivative you take 2 into y multiplied by derivative of y. That is y prime. Y prime is nothing but d over dx, as I told. D square over dx square is y double prime. Then we have taken the derivative of y square. Then we have to take the derivative of x square. Y square into derivative of x square is 2x. Plus third term, 3y. This term. Derivative is 3y prime. d over dx we represent as I said earlier, y prime, 3y dash. This is equal to plus the right side zero derivative is zero. Derivative of zero is zero. This is zero. So we have one derivative, second derivative only at minus 1 comma 1. That's this is x value, this is y value. So whenever x is there, we apply this minus 1. So 2 into minus 1 is minus 2 y prime. Minus 2 y prime is 2 into 1. Y is 1. Right? Minus 1, 1, we want 2 into 1 is 2 plus 2. Square into 2y into y dash. X square, x is minus 1, x square is plus 1. Minus 1 into minus 1 plus 1. 2y. 2 into y. 2 into 1 is 2. 1 multiplied by 2 multiplied by y prime. One term is this term. Y square is 1 into 1, 1. 1 into 2x. X is minus 1. So this is minus 2. So I am evaluating at minus 1, 1. This one at minus 1, 1. What is the value? That's what it is. This becomes. Hmm? So it becomes after finding the derivative, we substitute that for x minus 1, y 1. We got this minus 2 y prime plus 2 plus 1 into 2 into y dash minus 2. So this plus 2 and minus 2 will cancel. So we have got this equation plus 2 and minus 2 cancel. And here minus 2y dash y prime plus 2y prime. If you take one more derivative also, this will become minus 2y prime, y double prime. That will become 2y double prime. Y prime, if you take derivative, 2y double prime. This will become minus 2y double prime. That will become plus 2 double y prime. So these two also will cancel. It will become 0. So at minus 1 comma 1, d square y by dx square is 0. Most important thing is we cannot generalize it. See, we can find d square by dx square at a particular point minus 1 comma 1. Suppose instead of this, you want minus 1 comma 3, some other point you are given. You cannot find this way. Right? You have to do the same way, x minus 1 by 3. That's you have to substitute accordingly. So if you want the second derivative at a particular point, say minus 1 comma 1 or any other point, we can use this implicit differentiation technique. That means we don't express y in terms of x. We don't express. Directly we took the derivative, substitute the point x comma y where we want the derivative. We substituted, we got the values. This is called implicit differentiation.